Alright, the first thing, okay, let's all pay attention, we don't have much time. First thing, let's zero in on problems 18, 19, 23, 24, and 25. Because these are all properties, one property, and they don't require any work. You don't have to show any work for these. For number 18, 6 to the log base 6 of 10, the answer is 10. That's a property. You don't have to show any work. When these two numbers match, the answer is that other number. So when I look at number 19, 8 to the log base 8 of 2, the answer will be 2. Moses.
So when the base and the subscript match,
number 23. What's this one? And 24. Now, 25, we have to talk about. There are two main kinds of logarithms. There's the LOG log, which is called the common log. You might want to write this down somewhere, vocabulary. And common logarithms have a base of 10. That is understood. It isn't written. So when you see this LOG, you just know the base on that is 10. Because LOG is the symbol for base 10. So the answer to that problem would be 7. Now, the other main kind of logarithm is the natural logarithm, which is ln. You remember that? ln is the symbol for log base e. And we'll talk more about that when we get to it. But these are the two symbols. Actually, they're buttons on your calculator. These are the two that you need to be very aware of. When you see an LOG, you know the base is 10. When you see an LN, you know the base is E. All right, everybody okay with that property? So when we have a test or a quiz or an exam coming up, and it says 15 to the log base 15 of 7, you will all say the answer is 7. Easy, proper. Okay? Now, let's go back and look at the rest of the problems. They're pretty easy too, but they require work, a little bit of work. There are lots of ways to do the problems. I'm going to suggest that you just set each one of these equal to x, because you want to figure out, what is this equal? What does this thing equal? And then I want you to practice translating this logarithm equation into an exponential equation. So it becomes 5 to the x power equals 5. So 5 to the x equals 5. 5 to the x equals 5. Well, when you look at it like that, what's x equal? 5 to what power is 5? 1. So that's done. That's easy. Let's look at the next one. It's a little bit harder. Not really, though. Can you translate that for me? 4 to the x equals 16. Beautiful, 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 beautiful. So what's it equal? 2. 4 to the second? Yeah. Okay. Now here's the next one. And at first, you're a little bit baffled, but then you remember What does ln stand for? Log base e. So I'm going to think of this as log base e. ln is the same as log base e. So when I see an ln, I think of it as log base e. Now let's translate it. What will it say? E to the x equals e cubed? Well, wait a minute. E to what power is e cubed? 3. Wouldn't that be 3? Kids, that's like who's buried in grants too. E to what power is e cubed? Doesn't it have to be 3? Yeah. Try the next one. Set it equal to x. Now remember, when you just see a plain old log, what do you know? It's base 10. I'm going to put a 10 on there. Now let's translate it. 10 to the x equals 1,000. Do you know 10 to what power is 1,000? 3. 10 times 10 times 10. So far, so good? Okay, now it's a little wrinkle in here. Alright, so let's translate it. 4 to the x equals 1/16. What do you think? It's not 1/2, but you're kind of thinking in the right direction. -2. Remember, what does 1/over tell you? Doesn't it tell you there was a negative exponent? Yeah, because you flipped it. So this is 1/4 squared, right? Isn't that the same as 4 to the -2nd? So you're saying 4 to what power is the same as 4 to the -2nd? That would be -2. You do have to do some thinking with these guys. Some of them are a little bit tricky, for sure. What's this a symbol for? Base e. So let's translate it. 1/e cubed. And I got another 1/. What does a 1/? Mean? There's been a negative exponent. So e to the x is e to the -3rd. X equals -3. Translate this one for me. Not x to the power. 6 to the x equals a cube root of 6. Wait a minute. Cube root. What exponent is a cube root? What power? 1/3. It's a fraction.
Is it 1/216?
No.
1/36?
No. We're going to rewrite the cube root as a 1/3 power. Is that okay with everybody? Now, 6 to what power is 6 to the 1/3? 1/3. You're not cubing 6, Moses. That would be 216. You're not cubing it. You're cube rooting it. See the difference? Oh, here's a trick one. Remember, we're setting them all equal to x. And we're going to translate it. So what's it say when we translate it? So you gotta stop and ask yourself, what power can I raise something to get 1? Yeah, there you go. When you raise something to the 0 power, you get 1, right? Try 9. I think you can do 9 on your own. Try 9. Nothing tricky there. Did you figure out 9? What'd you get? 2. Very good. 7 to the x is 49, so x is 2. How many got that right? Super. Now, a little bit harder. First of all, what's the base? 10. So when I translate, it's going to be 10 to the x equals 110. Now, 1 over tells you what? Negative exponent. So this is 10 to the negative first. 1 over 10. It's 1 over 10 to the first. So it's 10 to the negative first. So what's the answer? Negative 1. Try 11. It's the same kind of problem. See if you can do it. Got an answer? Oh, if you said negative 2, you are right. Because this is 1 over 3 squared, which means the exponent is negative. Beautiful. All right. How about this one? What's the base? 10. So 10 to the x is 100, so x has to be 2. Would you try 13, 14, and 15 on your own? Give them a try. You can do it. Moses, why am I here talking?
The answer number 1 is 1. Number 2 is
All right, Moses has concluded that the answer to number 1 is 1. Would you agree with that?
Yeah.
6 to what power is 6? Moses says it's 1. 7 to what power is the square root of 7? Don't say something silly. You know that the square root is what exponent? 1/2. So therefore, x must be 1/2. Radicals are fractional exponents. Did you remember what ln stood for? Log base e. So when you translated this, it said e to the x equals e to the 10. So x equals 10. Do you remember the property we talked about at the very beginning of the period, where you had 8 to the log base a to 5, and the answer was 5, because these two numbers cancel each other out? You kind of have the same thing happening here. When these two numbers match, the answer will always be that number. So that has happened here, for example. That turned out just to be 1. So that will always work if that's a little shortcut you want to take advantage of. You don't have to, but you can. ln log base e. So e to the x equals the cube root of e. Now what do you know about the cube root of e? What does the cube root mean? 1/3. So e to the x equals e to the 1/3. So your answer is 1/3. Now, look at problem 20. Oh, wait. Did we do 17? Oh, okay, let's do 17, and then we'll look at problem 20. What are you going to do? So think of that as log base c. And as you get better and better, you may not need to write that step down. You might just think it, and then. And when you see 1/, you know what the exponent's negative. Yes, indeed. So the answer is -1. Everybody still okay? I know it's a lot of problems, but we just got to practice, practice, practice. Okay, now look at number 20. Now, be careful. Forget that for a minute. Okay? Can you solve this part? What does it say? 3 to the x equals 9. So x equals 2. So this part of the problem equals 2. But I got to times that by another 2. So the answer is actually 4. Does that make sense to you? So when you see the next one, you're going to do the same thing. It's 3 log base 2 of 8. Cover this up for a minute. Work this out. So 2 to the x equals 8. So doesn't x have to be 3? So this equals 3. Are you with me? Now, what do I need to do with that 3? I need to times it by another 3, so the answer is actually 9. Uh-oh, I should have done 24 before. Or 22, I mean. 22 says e to the log base c of 4. What's that equal? 4. Yeah, I should have done that one. Do 26. for a minute. Forget that. What's this equal? 1. 2 to the x equals 2. Doesn't x equal 1? So what's the final answer to the problem? 27. 6. Yeah, that's another one. It's e to the log base e of 6, so the answer is just 6. Figure out 28 for me. It's kind of tricky. It's 0. Very good. Number 28 says 8 to the x equals 1. What power do you raise things to get 1? The 0. Very good. Now, get your calculators out. This is easy. We're going to get this done in 4 minutes. Let's go. We're just typing in on our calculator. So everybody see your log button? It says LOG. So we log 8.61, and the answer is so we're logging 8.61, and the answer is 0.9350. It says round to the 10,000. That's 4 decimal places. 4 decimal places. Now what about B? ln 12. So I use my ln button. 2.4849. How about C? Yeah, C does not work. Boys and girls, you cannot take the logarithm of a negative number. The calculator will give you an error message. You cannot take the logarithm of a negative number. So the answer to C is no answer. How about F? No answer. G? No answer. If you forget that, and I hope you don't, I hope you remember that you can't take the log of a negative, but if you forget it, your calculator will catch it. D. Log 15.47. $1.1895. ln 1 divided by 23. Negative 3.1355. You can get negative answers. Yes, Lauren, good. You can get negative answers, you just can't put negatives in. One more, log 1977. 3.2960. And we got it done. I told you we would. Alright, your homework's in the book tonight. And I don't see you again until Thursday. So we'll pick back up here on Thursday. Harry, I gotta write you attention to that sweater. Unless, Harry,